We have already talked about combinations, but I will just do it again. So, combination is a selection of objects without regard to order. As we know, permutation is we consider the arrangement, we try to arrange them, but here we just have to select the objects. So, number of combinations is number of permutations divided by r factorial, and that's how we get the formula. And we've learned about the binomial coefficient. So NCR is n factorial divided by r factorial into n minus r factorial. Okay, let's take a few examples. Let's say there are 13 dancers in a class, and only 5 make it through to the finals. Not the finals, through let's say a competition. So what is the number of ways in which that can be done? It's going to be 13C 5, which is also equal to 13C 13 minus 5. We know this because 13 minus 5 people won't get selected, and therefore these two are equal. Also, we can take the example of a sport. Let's say there are about 50 people try out for the basketball team, and only 8 of them will make it. So the number of ways in which that can be done is 50C8. Here we don't have to worry about the order, because if you choose, let's say, a guy called B, a girl called A, and a girl called C, the order in which you arrange them or choose them won't matter. It's about these 3 people, and therefore order does not matter in combinations. That's the main difference between combination and a permutation. Time to do some questions. Let's look at the first one. How many different teams of 11 can be chosen from a squad of 17? This is very simple. So we know that there are a total of 17 people, out of which 11 have to be selected. And this is selection because of the word chosen. If it said how many different ways can 17 people be arranged, taken 11 at a time, then we would do permutation. But here, since they have been chosen, it means that we need to use combination. And we know that we have to use the NCR formula. Here n is 17, r is 11. Therefore, 17 C11 is 17 factorial divided by 11 factorial multiplied by 17 minus 11, which is 6 factorial. 17 into 16 into 15 into 14 into 13 to 12 divided by 6 factorial. Let's find this. This is 12,376. This is the number of ways in which a team of 11 can be made from a squad of 17 people. So this is how you approach questions. And now let's look at this one. Candidates for an examination are required to answer 5 out of 9 questions. In how many ways can the question be chosen if there are no restrictions? This is very straightforward. It's going to be 9C5 because I've already explained the reasoning behind this for the previous question. So 9C5 is 126 And if one question was compulsory, how many selections would be possible? So we know that if one question is compulsory, then we'd have to choose 4. So R would be 4 because we have to select 4 at a time. And we don't have 9 possibilities. We can't do that. So we don't have 9 available questions. We have 8 now, right? Because since one of them is compulsory, we don't have a choice to exclude it. And therefore, we have to remove that. And we're left with n equals to 8. And therefore, 8C4 would be our answer. This would be 70. I hope you've understood the reasoning behind this, because it's very important to know these questions, because they come in the past papers very frequently. Now let's solve the next one. This is easy. How many different committees of 3 people? 3 can be selected from 13 candidates. 13C3, because we're selecting 3 from the available 13 people. So 13C3, it's 286. That's the number of ways. All right. In how many ways can 4 people be selected from 10 if A, one particular person must be selected? If one person is selected, okay, let's just draw this. Let's say person C is getting selected. Now we have 3 slots or 3 places, and therefore we have R equals to 3. And since we've already chosen this person, we can exclude him from that group. So it's going to be 10 minus 1, which is 9. So n is 9. NCR would be 9C3, which is 84. This is the answer to part A. Now let's look at B. 2 particular people are excluded from every selection. So these people are not included in the group. So 4 empty spaces. And if they have to be excluded, that means we have to take them out of the group of people that might be selected. So it's going to be minus 2, 8. We have to choose, we have to do 8C4, which is 70. This is the answer. So we're done with these 4 questions. Let's solve some more. Since we're done with these 4, let's move on to the next 2. Determine whether the following are examples of combinations or permutation. Making a 3-digit number using the digits 1, 2, 3, 4, 5 at most once each. This is permutation, because in this the order matters, because 1, 2, 3 is not the same as 2, 1, 3, and therefore this would be permutation. The first one is permutation. Selecting a committee of 3 from a list of 5. This is combination, because the order does not matter. And now selecting the chairperson and the treasurer from a committee of 8 people. In this one, the order matters, because let's say if a guy called A and a guy called B, the first one is the chairperson and the second one is the treasurer, but it can also be the other way around, right? So therefore here permutation is more apt. And then selecting 2 pieces of fruit to take to school from a bowl of 10 pieces, this will be combination, because it does not matter whether you take an orange first and then a banana, or like a banana and then an orange. So it's combination. I hope these examples made it much more clear and you do understand the difference between combination and permutation. And now let's look at this. These are the type of questions that you will often get. So let's do this. A committee of 8 is chosen from 9 boys and 6 girls. Find the number of ways it can be done if there are no restrictions. If there are no restrictions, we have to choose 8 from a total of 15. So it's going to be 15C8. This is 6,435. And there must be 5 boys and 3 girls. If we choose 3 girls, from 6 we have 6C3 into 5 from 9. So 9C5. This is how we do it. So it's going to be 6C3 into 9C5. This is going to be 2,520. This is the answer. And now if all the girls are selected, that means, but we don't have enough girls, right? Wait, never mind. All girls are selected. It means 6 girls, 2 boys. So 6 girls, 2 boys. And this can be done in one way, because if you choose all of the girls, there's only one combination. And if we can choose 2 boys from 9 in 9C2 ways, which is 36. That's the answer. That's how you derive it. And now let's look at D. This is somewhat complicated, but it's not that complicated also. If there are more boys than girls, we have to write down every single possibility. So wait, I'll show you. Let's take scenario 1. Eight boys, 0 girls. There are more boys than girls, so it's going to be 8, 9C8, which is 9. Yes, 9 ways. 7 boys, 1 girl. That's going to be 9C7 into 6C1, which is 216. And now we'll write 6 boys, 2 girls. It's going to be 9C6 into 6C2. It's 1,260. Now 5 boys, 3 girls. We already found this out in B, which is 2,520. Therefore, total is 9 plus 216 plus 1260 plus 2520. 20. Let's add this up. We get 4,005. This is the final answer. And now we're done with the questions I picked out for combinations.